NASA's James Webb Space Telescope. Hello and welcome to our channel, Fun Techs and New Ideas. Today we're going to discuss the latest development made by NASA's James Webb Space Telescope, or JWST for short. In this video, we will discuss all the latest images captured by the James Webb Telescope and try to understand the hidden secrets of our galaxy in the easiest way. So, without further ado, let's get started. What is James Webb Space Telescope? The first question is, what exactly is James Webb? So, the James Webb Space Telescope is a space telescope principally built for infrared astronomy. As the largest optical telescope in orbit, its much increased infrared precision and sensitivity enable it to examine objects that the Hubble Space Telescope cannot see because they are too early, far, or dim. This is planned to enable a wide range of astronomical and cosmological inquiries, such as the detection of the earliest stars and the development of the first galaxies, as well as the thorough atmospheric characterization of possibly habitable exoplanets. The James Webb Space Telescope was flown on an Ariane 5 rocket from Kourou, French Guiana on December 25, 2021. Recent development. Now we understand what exactly the James Webb Telescope is, so we are now ready to move forward. Webb was built to collect light from the full red to mid-infrared spectrum wavelengths of light that the Earth's atmosphere blocks. With its massive mirror and sunshade filtering infrared generated by the Sun, the Earth and the Moon, Webb can create images of unprecedented quality. Since members of the Webb team revealed enticing test photographs, the buzz among professional astronomers has been explosive, and the real-world photographs are even greater than anyone could have imagined. There is no empty sky for Webb. Everywhere it looks, it detects faraway galaxies. Webb research scientist Jane Rigby said during the conference where the first photographs were revealed, most of those galaxies were previously unseen. Early universe. The very first Webb image that the public saw was of a galaxy cluster dubbed SMACS 0723. It is located in the southern hemisphere sky, 5.12 billion light-years away from Earth. The image's detail of thousands of individual galaxies is breathtaking. It's like seeing the galaxy in full definition. Anyone can view the full resolution image and zoom in to really appreciate the subtleties. The big white galaxies in the center of the photograph are part of the cluster and are roughly the same age as the Sun and Earth. Additional distant galaxies encircle and are interspersed among the cluster galaxies, but they are stretched into stunning arcs as if seen through a magnifying glass. That is precisely what is happening. The background galaxies are quite far away from Earth, but their light is deflected toward Earth by the gravity of the nearby cluster, making them look magnified. In the backdrop, you can see bright red galaxies spread throughout the sky like rubies. Those galaxies are even further away. Astronomers can detect that they originated over 13 billion years ago by analyzing specific properties of their light, and they can even measure the quantity of certain elements in these ancient galaxies. The Webb not only produces exceptionally fine images, but it does it with greater ease than its precursor, the Hubble Space Telescope, which was released in 1990. The Hubble Incredibly Deep Field takes 2 weeks of exposure. Webb goes much deeper before breakfast, Rigby joked. Astronomers will be able to glimpse a few of the earlier stars and galaxies that emerged shortly after the Big Bang once Webb conducts extended observations that enable it to gather more light from dim stars or galaxies. The second revelation was a spectrum, which is a breakdown of the brightness of light at different wavelengths. Webb aimed its mirror at WASP 96-b, a large hot gas planet orbiting a star about 1,000 light-years from Earth, as the planet passed in front of its parent star. A fraction of the star's light passed through the planet's atmosphere during its transit, leaving a chemical fingerprint in the light's peculiar spectrum. The characteristics of this fingerprint strongly indicate that water vapor, clouds, and haze exist in the environment of WASP 96-b. Astronomers anticipate discovering the fingerprints of oxygen, nitrogen, ammonia, and carbon in the shape of methane and other hydrocarbons as Webb proceeds on to investigate tiny planets that could potentially harbor life. The objective is to uncover biosignatures of existence, or chemistry that indicates that living beings have altered the atmosphere. The technological barrier of performing this type of observation, known as transit spectroscopy, is considerable, and this preliminary result only scratches the surface of the spectrum's scientific phenomena. The last three images demonstrated Webb optics' amazing resolution as the telescope investigated the birth and destruction of stars. Webb's capacity to collect light in the mid-infrared region enables its cameras to penetrate through thick clouds of dust and gas. This feature aided Webb in capturing amazing characteristics of the Carina Nebula, the birthplace of stars. Webb is also well suited to investigate the conclusion of a star's life. As stars age, their surface layers can blast off and create nebulas, like the magnificent Southern Ring Nebula, which was photographed by Webb. The photograph showed previously unseen characteristics of the fading core star's successive waves of material. While Hubble failed to penetrate the growing cloud of dust and debris, Webb gave the first view of the nebula's binary star system. In the final photo from Webb's going out celebration, Stephan's quintet, a set of 5 galaxies 300 million light-years from Earth, interacted in a cosmic ballet. The telescope can instantaneously pick up details of independent stars in these galaxies. Imagine the coal dust and gas fueling star formation within these galaxies, and most impressively, block out the stars, gas and dust to observe the material roiling around the supermassive black hole at the center of one of the galaxies. Webb also collected spectral data from hundreds of distinct star-forming locations in the quintet, which will take several months to examine and research. Webb is the culmination of 25 years of effort by hundreds of scientists, engineers, and officials from a global alliance of space agencies, industries, research institutions, and universities. Webb project head John Mather characterized the journey passionately. This was a difficult task. It's tough to put into words how painful this was. There were literally thousands of possible outcomes. But nothing went wrong. It all came together perfectly, and humanity's largest space telescope is now operational. I hope you liked the video. Please like and subscribe to our channel. Thank you.